the planet is being powered by solar energy right now, even though you may not realize it. So the gasoline that you run your car in was produced by plants and from solar energy. And so over the billion years or so of Earth's history, the plants and other photosynthetic organisms have had an excess production over what they needed. And so this is in the form of wood and other biomass that gets buried. It's been buried over the millions and billions of years. And that's where all the fossil fuels came from, is from biomass that got buried and then over geologic time got converted into coal or oil, crude oil. And so we're collecting that right now. So we're basically using fossilized solar energy. And it's not sustainable because it took the Earth a billion years to generate all these fossil fuels, and we're burning them up at a rate that they'll be gone in a few hundred years. And so there has to be a sustainable process figured out. And so our thought is, well, this has powered the planet up until now. Can we do the same kind of process, emulating how the natural system does it, but in an artificial process that could be done on a large scale? And so there's a lot of questions how to do that right now. There isn't any working process to harvest solar energy, not economic process to harvest solar energy on this scale. And there's lots of ideas, and we don't really know which one might be the one that will ultimately prevail. But I believe that solar energy has to power the planet in the future, and we have to come up with a renewable, sustainable way to do that. And so that's underline my interest in the research we do. What we proposed to do was to take manganese catalysts that we've made. Professor Crabtree and I, working together, have developed some manganese catalysts that can do oxidation of water. And we wanted to link them onto photochemically active nanoparticles to use light to drive that make that reaction happen. So the accomplishments X, Y, and Z were first develop ways to link them together. A manganese complex to link it onto a nanoparticle. So we were working on mechanism, the chemistry to make those attachments. And that's one success, if we can make those attachments. The other is to use light to make the reaction happen. And the goal is to make the light, to use light to make oxygen from water. But some of the steps along the way would be to use light to make the first step, just have a photochemical reaction happen to measure that actually did take place, not the whole reaction necessarily. So we were looking at individual steps along the way to the final reaction. And we've made some progress on that, but we haven't yet succeeded in actually using light to make oxygen from water, which is the goal of the project. So you might ask, where is the fuel? So plants use light to make oxygen from water, and all of the oxygen in the atmosphere came from photosynthesis. So we, of course, breathe that oxygen. It's essential for all air-breathing organisms like us that plants make oxygen. So why do they make oxygen? Oxygen is not the fuel. Well, the fuel is the electrons that are stripped out of water to make oxygen from water. Those electrons are used to make a fuel. And a fuel is basically a molecule that has more excess electrons. And then you can burn it. It'll combine with oxygen. Those electrons will be given back to the oxygen, and that's what a combustion reaction is. And so it's the electrons which is the energy currency to make a fuel. So if you can make those electrons, you've solved the problem, basically. At least the hard part of the problem is to generate those. So that's why our project was funded, because we're working to try to come up with a way to make the electrons. Ultimately, that's not something that we've been focusing on, but ultimately those electrons have to be used to make some kind of fuel. Maybe make hydrogen gas, or maybe make ethanol or methanol, or something that can be used as a fuel. Ultimately, if we're going to make something that could be usable, we have to couple the reaction that makes the electrons to another reaction that absorbs the electrons and converts it into a fuel. But we have to solve the first problem first before we get there. And I think it's widely recognized that the water oxidation reaction to make oxygen from water is the real bottleneck. But the bottleneck in research really is clever people and good ideas, and making that into new results. What I would hope is that there would be a possibility of having a solar cell in which you could make a fuel directly from light. Right now, solar cells make electricity, and one of the big limitations of making a solar farm with solar cells as they're generated right now is that we don't have any way of storing electricity. and we can't also can't transport it very long distances without losing a lot of it. So, you know, there's huge areas where there's lots of sunlight and areas which aren't very productive for agriculture, and you know, there are desert areas that could be solar farms, but they're very far away from population centers. And so how do you get the energy to the population center? You can't store the electricity, you can't transfer the electricity, so it's just basically can't be used. But if you could make fuel directly from sunlight, then you could transport the fuel like we transport oil or, you know, gas in pipelines or tankers. And so that's what I would envision be in the future.